All right, now we're going to do the next section. Chapter 5, Section 4. The properties of logs. I'm going to state all the properties first, and then we'll do the examples. So the first property is the product rule. It says this: if I have a log of two numbers multiplied to each other, since I am multiplying, when you multiply things, you make them bigger. So that's what we can split them up and add them. So if you're multiplying, you can split them up as make an addition of two separate ones. The second one is a power rule. If you take the log of a number to a power, that power goes in front. The third one is called the quotient rule. When you divide things, you make them smaller. So this is why we use subtraction. Well, we have two more. The logarithmic of a base to a power. So it says here's this. Here we use a couple of the properties. First, we have the power rule. What happens to that x? Where does it go? This page, I don't know why it's coming back. Power rule says this exponent goes in front. And an earlier rule, what is log base a of a? If you have the same base as the operation, what does it become? 1. So if you have the log base a of a to a power x, it just becomes a power. No, yeah. Let me see what that one. That's what it's called. To a base to a logarithmic power. What this one says, if my base is a, and I have as an exponent log with the same base, that also just equals x. So let's look at these proper formulas. I mean the examples now. So these are the 5 properties we'll be using to solve these equations. Example 1. Express this. This is 9 times 27. Express that using the properties. So what property are we going to use? First one, right? So we'll have log base 3 of 9 plus the log base 3 of 27. Combine these two. So since the bases are the same and they're added, there's my answer. Just combine the two numbers. Example 3. Express each as a product, okay? Log base A of 11 of negative 3. So what's that going to equal? Remember, you can't have exponents. So this exponent goes out in front. So it's negative 3 times log base A of 11. Log base A of the 4th root of 7. You may have gotten here after I talked about this. The logarithms, like if we had square root of x, and this is power of x is power of 1. It's just, since this is square root, there's an invisible 2 there. I can rewrite this as a fraction. Whatever the root is goes on the bottom. So if I had n x to the power m, I can put this as an exponent where this m is on top and this root goes on the bottom. So we can rewrite this equation as what? Whatever's inside the radical is 7. What is its exponent? Since there's nothing there, it's a 1. And the root is 4. This is an exponent. It goes out in front. So it's 1/4 log base A of 7. ln x to the 6th. How about this one? 6 ln x. Because it's an exponent, it goes out in front. There's your answer. Pretty straightforward so far. Let's do quotients now. Example 4. Log base t of 8 over w. Rewrite that. How would you rewrite that? Log base t of what? 8 minus, very good. Log base t of w. Yeah, perfect. Remember, it's equal. You should be able to go both ways. If I gave you this, you can go to this. But if I gave you this, you should give me this. Which is what example 5 says. Log base b of 64 minus log base b of 16. But the only thing is the bases have to be the same. If they're not the same, you can't do anything. You have to treat them both separately as best you can. So what's this one equal? So what this one equals is log base b of 4. Because 64 over 16 is 4. So all depends on what the question is asking you. Like this one says, express as a single logarithm. Well, that's a single logarithm. So is this. It's simplified. So whatever it's asking. Oh, here's some common errors. Don't do that. They don't equal each other. Those don't equal each other. Nope. These are the 4 most common mistakes that people do when they start using logarithms. Why? What's wrong with this one? Why isn't it that? Because the real rule is this. The exponent belongs to the m only, not to the whole thing. Let's say we had log base, whatever, of x to the power 3. Let's prove this rule. Let's prove this rule. What this means is log x times log x times log x. But log x to the third means log x times x times x. Which means, how do we expand the multiplication? Log x plus log x plus log x, which makes it 3 log x's. So there's a difference between the two. If it's outside the parentheses, that's what that means. But if it's inside, only x is multiplied, then we can follow the rule still. Okay, let's look at rule example 6. Let's apply these properties now. This is the fun part. Expand these. Log base 4 of x squared y fifth over z to the fourth. So what's the most obvious rule to use right here? The quotient. So we'll have log base 4 of x squared y to the fifth minus log base 4 of z to the fourth. Now we can expand this one. X squared plus y to the fifth. Now, since all of these have exponents, those exponents go out front. So we have 2 log to the fourth of x plus log x base 4 of y minus 4 log base 4 of z. That's your answer. Can't go any further. So far, so good. Yeah, now, let's look at going backwards. If it has a plus in front of it, if it's a positive in front of the number, it will be on top. If it has a minus, it's going to be on the bottom. If it has a coefficient, that coefficient goes as an exponent. And they're all log base 4s. So it's all log base 4s. This is x squared. That's y squared. And I'm added. So those go. This is a minus. So it's z to the fourth. We can go. We have to be able to go both ways. Print this one. What's the first thing you're going to do? Get rid of the coefficients. The coefficients become exponents. They're all log base b. Some are positive, some are negative. So if it has a negative, it goes on the bottom. If it's positive in front, it goes on top. We cannot have, this is 1/4. We cannot have a fraction as an exponent. So how do you rewrite that one? How do we rewrite that one? Remember the rule. When it has equal sign, you should be able to go both directions. If I give you a radical, you can put in exponents. If I give you an exponent, you put it back in radicals. If it's a fraction, it's a radical. Whatever's on the bottom is the root. So it's the 4th root of z to the first power. How would you put these two in radicals? What's the first one going to be? Cube root of x squared. What's this one? 5th root of y to the first. Yeah. That's it. Let's combine some of the stuff we've did during the semester. Example 8. Express as a single logarithm. It's minus, so what do we do there? The quotient rule. So 3x plus 1 on top, 3x squared minus 5x minus 2 on the bottom. And we are not done. Factor the bottom because it's a polynomial. Factor it. Since the leading term is 3x squared, I have 3x and 3x. Second sign's a minus, so they're opposite signs. The bigger number gets the negative. Multiply the first and the last term. 3 times 2 is 6. What two numbers multiply to give me 6? When I subtract them, I get 5. What two numbers multiply give you 6? 2 times 3 or 6 and 1. 6 times 1 is 6. 6 minus 1 is 5. The bigger number gets the negative. So that's a 6 and that's a 1. Can we factor anything out of this one? No, they're both prime numbers. Can we factor anything out of this one? A 3. So we divide both of these by 3, gives us x minus 2. Erase that. The 3x plus 1's cancel. So there's my answer. Example 9 says log base a of 2 is equal to 0.301 and log base a of 3 is 0.477. Let's find these. So it's log base a of 6, log base a of 2 over 3, log base a of 81, log base a of 1/4, log base a of 5, that's F, log base a of 3 over log base a of 2. What this example is wanting you to do is to rewrite these so we can start using the rules. So for example, the first one, log base a of 6. What do we do there? Because we don't have, all we have is log base a of 2 and log base a of 3. We don't have log base a of 6 or 81. So let's rewrite this. What is 6 made up of? 2 times 3. Log base a of 2 times 3, since it's multiplied, it's a product rule. So now we have log base 2, log base a of 2 is 301 and 477. All we do is add those two numbers together. Is 0.778. Example 2. We can just go ahead and just put that straight up into the quotient, the quotient rule. Log base a of 2 minus log base a of 3. 301 minus 0.477. The answer is going to be negative. So 477 minus 301, it's 176. How about 81? What is 81 made up of? 9 times 9. Very good. So this could be written as log base a of 9 squared got an exponent, so it's 2 log base a of 9. So how does 9 relate to one of these two guys? What is 9 made up of? 3 times 3. So we got 2 log base a of 3 squared. Again, another exponent, bring it down. So we have 2 times 2 is 4 log base a of 3. Log base a of 3 is 0.477. $1.908. It's 4 times log base a of 3. Log base a of 3 is 4.477. So we do the same thing in this one. Log base a of 1 minus log base a of 4. What's log base a of 1? 0. Very good. That's 0. So we have negative. 4 is made up of 2 times 2. So that exponent goes out in front. So it's negative 2 log base a of 2. And log base a of 2 is 0.301. Answer would be negative 0.602. How about the next one? Can we do anything with that one? Well, doesn't 5 come from 3 plus 2? Can we do anything with that? Common errors. You cannot add inside a logarithm. So this one is as far as it goes. We would have to use the change of base formula, or just leave it as it is, since all we're given is log base 2 and log base 3. So this is as far as it goes. How about the last one? Well, log base a of 3 is 0.477, and the other one is 3.01. We do that, just we poke that into the calculator and we get an answer. So that, be very careful when you're given these type of questions, because you will be given in the homework assignments those kind of questions. All right, the last two examples are just straightforward from the last rules we talked about. Example 10. So what's the rule here? Well, we could go back to the basics. If you have an exponent, that goes out in front. And log base a of a is 1. Or we can go to the other rule we learned, that if you have the base and the base are both the same, it's just the exponent. How about this one? Why is this one negative t? What is ln? Log base e of negative t. Since they're the same, they cancel out. And there's no base here. Since it's a common log, it's base 10. Since they're the same, they cancel. We'll just have 3k. And these are the last three. The rule we had here was this. If the base and the base are the same, it's just what the operation is. The base is 4. The base of this is 4. So the answer is K. Ln is log base E of 5. The bases are the same, so it's just 5. This is a common log. If there's nothing there, it's automatically a base 10. Since the bases are the same, it's just the operation. So these are your answers. Again, all of these are doable if you use the formulas we use in the first page. All right, that does it for that section. And we'll finish up because section 5, it's just now let's apply everything we've learned, all the rules, and start solving equations. And then after that, we do chapter 6, the 2 sections there. And those all go together in one lesson. It deals with solving systems of equations. We'll talk about that next time. So we'll meet Monday, or you want to meet the Monday after? Because if we meet Monday, then we're going to finish up everything we can, and then it'll be done. So you have the week after that to catch up everything. Or you could spend your Thanksgiving break catching up, which you probably won't do, because I know I don't do that.